Hi, I'm Herc.
And I'm Velocity, and this is Leica. Last month we told you about telescopes that you can use in your backyard. Today we're going to tell you about the big telescopes used by professional astronomers. They're really amazing.
Let's Explore Astronomy is sponsored in part by When most people think of telescopes, they think of optical telescopes. That is, the telescope sees the same thing as our eyes.
The telescopes we use in our backyards are optical telescopes.
Right. But the human eye can only see a small portion of the electromagnetic spectrum. There are many different wavelengths we cannot see with our eyes, but specialized instruments can.
And they all show and tell us something different about what we are looking at.
So today we are going to take you around the world and even into outer space to show you the different types of telescopes and what they do. But let's start with optical scopes. We are at Apache Point Observatory in New Mexico, where they have several optical scopes studying deep space.
We are now inside the dome looking at a 3.5 meter scope. It's an optical scope. But you don't look through an eyepiece on this one. It is hooked up to cameras and computer instruments.
This is typical of many of the world's huge telescopes. This particular scope has 6 main instruments that looks at the wavelength range from 3,200 angstroms to 10,000 angstroms. The electromagnetic spectrum is measured in a unit called angstroms. As you can see from this diagram, the light we can see with our eyes, called visible light, runs from about 4,000 to 7,000 angstroms. So this scope can see everything the human eye can, as well as a little of the infrared and ultraviolet light.
By looking at different wavelengths produced by objects, astronomers can determine all kinds of things, like what the object is made of, what chemicals are in it, how it works, what it is doing, and more.
In future episodes, we will get into more detail and explain how the information gathered from these scopes is unlocking the secrets of deep space objects.
You know, Herc, the air is really thin up here at the top of the mountain. It gets hard to breathe sometimes. Why did they put the observatory way up here?
Well, Velocity, ground-based telescopes, whether it is your telescope in your backyard or one of these huge several-meter scopes, all have the same problem: pollution. Not just the pollution put into the air by cars and factories, but also light pollution, and the atmosphere contains moisture, which interferes with the view of the telescopes too. So the higher up one can put your telescope, the clearer the air from all that interference.
So the best place to be would actually be outside the atmosphere? Like in space?
Correct. And that is why a lot of observatories are actually in space. The most famous of all the optical telescopes is in space, the Hubble Space Telescope. And we have all seen the amazing photos from Hubble. Thanks to no atmosphere to interfere, the Hubble can obtain pure, clear, sharp photos of deep space.
I hear an even bigger space telescope is being made.
Right, the James Webb Space Telescope will be launched in the next few years. One can only imagine what that will see. There are observatories that look at everything in space. This is Sunspot Observatory, and as the name implies, it spends its time looking at the sun.
The sun is the closest star to Earth, so by studying the sun, we are also studying the other stars. Plus, the sun affects life on Earth in every way, so it is a good idea to know all about it.
On future episodes, we will tell you all about our star, the sun, and also head to the Yukon to see the sun put on the show we call the Northern Lights. But now, let's continue our look at telescopes and leave the world we can see behind. As you can see in this diagram, there are wavelengths outside the visible spectrum, such as gamma rays and X-rays and radio waves. Back in 1933, Karl Jansky was working for Bell Telephone, trying to figure out why there was static interference on transatlantic communications. He set up some equipment and discovered that noise was coming from outer space.
It's the aliens! Run for your lives!
No, it was not aliens. What they found was that deep space objects, such as pulsars, emit radio waves. The universe is actually full of radio waves. So a whole new field of astronomy was invented. Radio astronomy.
I wish it was aliens.
Well, you never know. In fact, there are radio telescopes today listening to the universe in hopes of finding a transmission from another world. Think about this. All the radio and TV programs we broadcast here on Earth over the last nearly 100 years have all gone out into space. Someday they will reach a distant planet, and if there is life there that have radio telescopes, they will pick up our shows. So the reverse works too. If aliens sent out broadcasts, eventually they might just pass by Earth. So there are people listening for that. But the vast amount of radio astronomy is done to understand the universe.
Telescopes can also be used to receive radio waves. This is the Very Large Array in New Mexico. Those are actually telescopes, but they are radio telescopes. They are shaped like large dishes that gather the radio waves coming from outer space. Here at the Very Large Array, they use 27 of these antennas all combined together. Each dish is 25 meters or about 82 feet across. When hooked together, they make an antenna with a sensitivity of a dish that would be 130 meters or 422 feet across. They need to do that because the sounds from space are so faint that you need a big scope as possible. Hey, Herc! Hey, Herc, where are you?
Here I am. I am at Arecibo in Puerto Rico. Here at Arecibo, they did something different. Instead of 27 smaller dishes tied together, they built one really big, huge one. The Arecibo telescope is 1,000 feet across, over 300 meters. It is the largest single-unit radio telescope in the world. Did you notice yet that a radio telescope is much like a reflector telescope? The waves hit the curved dish and are reflected back, focusing on the antenna structure hanging above it.
So what can we hear and learn with radio telescopes?
With radio telescopes, we can look way back in time. We can actually observe the cosmic microwave background radiation that was from the birth of the universe. We can probe the first stars and galaxies and explore black holes.
Also, a lot of the universe is hard to see with visible light because the cosmic dust, like a nebula where the stars are being born. Radio waves can cut through the dust so we can study what's going on inside. Hey, Herc, how did you get to Puerto Rico so fast?
I took a cab.
You can't take a cab to Puerto Rico. It's an island, and it's thousands of miles away from here.
Wormhole?
No way.
In addition to radio waves, there are other types of waves that are invisible to us, including X-rays and gamma rays.
A lot of radiation is actually harmful to humans. Fortunately, Earth's atmosphere blocks out most of the harmful radiation traveling through the universe. But that does no help to astronomers who want to study it. So the best place for X-rays and gamma ray telescopes is in outer space.
The Chandra X-ray Observatory is one such example. It is in orbit above Earth's atmosphere. X-ray scopes need to be coated with gold or other metals like beryllium, and the mirrors have to be a shallow angle of reflection because the wavelengths of X-rays are so short. Chandra uses parabolic cylindrical and hyperbolic cylindrical mirrors.
We've all seen X-rays. Your dentist takes X-rays of your mouth. Actually, he puts film in your mouth and then shoots X-rays through your jaws at the film. That's what he puts in your mouth! He said, bite down on this. I thought it was a piece of gum. The teeth block the X-rays, but skin does not. So on the film you see your teeth and any holes or cavities.
Many things in space give off X-rays, including black holes. The X-ray telescope on a satellite records the X-rays as they travel across space, and by measuring the photons of X-ray light and energy, we can learn more about the object it came from, much like your dentist or doctor uses them to learn more about the inside of your body.
Gamma rays are even shorter than X-rays. They are so short that you cannot use a mirror to detect them. You need a telescope of crystals.
Gamma rays have the most energy of any wave in the electromagnetic spectrum and are found in nuclear explosions, lightning, black holes, neutron stars, and pulsars. Scientists can use gamma rays to determine the elements of other planets. Here is a map of hydrogen concentration on Mars, gathered from observing gamma rays.
Even though we can't see other wavelengths, computers can convert the data into a form that we can see so that we can compare. This is how the Milky Way looks to our eyes.
And here is the same view in the infrared wavelength.
And this is how a radio telescope sees it.
Here's what the Milky Way looks like in X-ray.
And this is gamma rays in the Milky Way.
All captured with telescopes. Astronomy is a huge science. It takes many types of scientists and equipment to unlock its mysteries.
So join us each week as we continue to explore the universe. Let's explore astronomy!
Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.